Next, let's invite another distinguished guest. He's the chief scientist of the National Supercomputing Shenzhen Center, Dr. Feng Shengzhong. Dr. Feng will share scientific and technological innovation to support the development of the Guangdong, Hong Kong, Macau, Greater Bay Area, and the whole country, and how to promote the sustainability development of the economy and social and industrial upgrading. So let's welcome Dr. Feng Shenzhong remotely.
Good morning, ladies and gentlemen. It's my honor to be here to share my topic on computing power. Now, today, I will talk about the high-quality development, the opportunity and the challenges. I will present my talk in Chinese. 女士们、先生们，非常高兴。
Gentlemen, I'm very honored to have the chance to share with you my observation on the opportunities and challenges of the high-quality development of the computing power empowerment. In the past half year, since the end of last year, the high-quality development of computing power is a hot topic by many people. But what is the background? I think it is closely related to ChatGPT's birth. I know that ChatGPT, many people wonder whether ChatGPT will bring about a breakthrough for the industry, whether it will have a very profound impact or revolutionary impact on the industry. But so far, we can see that there's still some distance. But how about computing power? Computing power is the basis. Without it, we cannot carry out our work in a high-level way. So how to guarantee high-quality development? It relies on innovation. And for computing power, is it a natural result of innovation, whether it will be converted to productivity, and what is the cost of computing power? How about its efficiency, and how to evaluate its efficiency? So all these questions should be answered. It is a common concern of all practitioners in an industry. We should say that in GBA area, we are faced with an unprecedented opportunity that is unseen for a century. So now we are at this threshold to face these abrupt and great change. We need innovation to realize sustainable development and high-quality development, including the transformation and upgrading of the industry. So all these requires us to have technological breakthroughs in the past 500 years. During the technological innovation and revolution, we can see that it is a certain release of some interests and different powers. And for the first industry revolution, it is the release of the dynamic power. And we are turning coals to fuel, to energy, and to the driving power. And it brings about development in transportation, textile, and railway. And the second industrial revolution is marked by electricity. And many industries have gained revolutionary breakthroughs. And the third industrial revolution released a quantum. That is the power of the atomic. After the Second World War, the computing power was released. And that brings about development in telecommunication and many other aspects of the society. And in the last 3 to 8 decades, we have seen its profound impact. And about 1 century ago, and half a century ago, society was much different from nowadays. For example, the invention of telephone and mobile phone, internet, it makes possible the global village. But the supporting power is the computing power. Without computing power, we cannot enjoy all the conveniences brought by this technology. And now we can search easily online, and we can watch any videos on our mobile phone. So this is thanks to the revolution of computing power. And in the future, what role will computing power continue to play? We think that it is the key support of a new technological innovation. It will have even more profound impact and influence. And now we are faced with some great challenges and opportunities. First, when we talk about innovation, actually, the most difficult part of innovation is in its technical part. We have a phrase that is a innovation death of technology. So there are different innovation in terms of technology product and the commodity. And for example, WeChat, a mobile phone is the product innovation. And where is the technological innovation? Especially for those major technological innovation, where it lies in. It depends on computing power. And computing power is the crucial pillar for technological innovation.
国家可以说不
The GBA is very well and not advanced as almost as the advanced countries, but the computing power development is quite uneven across the country, and we are only 1/3 of the developed countries in terms of computing power. And that is Shenzhen, and Hong Kong probably is even lagging further behind. After 3 decades of development, Hong Kong and Guangdong and the GBA area has been improved exponentially in terms of the high-tech innovation infrastructure. And there is emerging top world scientists in this area. What kind of platforms do they need? And without the computing power, they cannot conduct their day-to-day research work. Hong Kong Science Technology University, Hong Kong Chinese University, Hong Kong University are home to a lot of the top scientists and professors, and they require computing power for their research work. Hong Kong and also Shenzhen are places where there is a lot of risks. And probably this is the area that hosts the most high-rises buildings. And this also poses new requirements on the infrastructure. And we would like to uplift the current infrastructure into the 100-meter level. And in Shenzhen, there are companies like BYD and Tencent, as well as Huawei, which are all leaders in their individual sector. And all these companies have huge demands for computing power. And there are also a lot of SMEs. These SMEs, they also are having a lot of practical requirements on computing power, be it SME in big data, AI, or SMEs in the traditional manufacturing industry. They all have requirements on computing power. But we have a lot of science and technology institutions that are developing, including a lot of the labs. For example, the South Science and Technology University, they also have a lot of infrastructures and labs and institutions. So the big computing power can address big problems. Computing power can create miracles. Let's think about the cities in 50 years' time, transportation in 50 years, and these are all major social issues. Take transportation, for example, and Shenzhen transitioned in 20, 30 years into the city that it is today. So if the next 50 years is going to develop as fast as how we developed in the previous 30 years, then the city is not be very inhabitable, because right now we're already suffering from traffic jams. So how is healthcare going to evolve in 50 years? How is education going to develop in 50 years? These are all important social problems we need to address. And how does the brain memorize and think? And there's a lot of weaknesses we have now in our current education structure. And how do you think the cancer will be curable in the future? And what about safety? And what about new materials? These all require big computing power. The only solution is technology. And to have the technology, we rely heavily on computing power. So we talk about all these uplifting or great improvement on computing power. And can we just go buy those big brands? And that's not enough. For the computing power, we need multiple efforts, to address these imminent needs to further develop our society. Materials, computing. You may think materials computing is a scientific exploration, and it's more than that. Have you ever analyzed in depth how BYD does this? BYD has done a lot of computing in materials, and there is also batteries, and there's also computing in the vehicles, etc. Without computing, just having the experiments are not enough. You need to have a huge amount of computing to make sure that the vehicles are safe, and to make sure that these vehicles can keep us safe on the road. And this all requires huge computing. So computing helps to make companies stay competitive. And there's also, for example, our commercial vehicle, and also the structure of the yacht. And all these important major engineering works require huge computing power. We have done some initial statistics for GBA, including Hong Kong and Shenzhen. So the computing power required in this region is more than 10 billion, which is also increasing very rapidly. So our requirements are changing, are constantly changing. And of course, how we innovate will change, and how much computing power we need is also changing. So we need to view the computing power required in a changing manner. So have we already solved all the problems? Not yet. We're still faced with many major challenges. For example, the first one is a balanced design. How can we strike a balance, between energy efficiency and also the performance, we need a systematic solution. And also, we need our system to be able to handle large amount of data and also to perform a complicated algorithm. So that requires a highly expandable and storage as well as network. And also reliability is key. You may think reliability is not that relevant to us, but actually reliability equals to productivity. Without reliability, you do not have productivity. We have some of the tasks on the computing platform, and the computing power may break down before it performs that task. So how can you have productivity? So that's how important reliability is. 10, 20 years ago, and we were quite restricted with reliability. So we were using Word or Excel, and all of a sudden the computer may break down. And if we're going to use a large computing platform, is the same breakdown going to happen? And how do we address this problem? That's also a challenge. And also high usability. That's another challenge. And also how to guarantee the right maintenance of the system in a highly efficient way. The computing density right now is very high, and the one cabinet was maybe 10 million, and now it's hundreds of million, and this energy consumption density is increasing rapidly, and this is a huge challenge for us. There another challenge is on safety. How can we make sure that the system stays safe? And this is a challenge that is increasing on the day. And more importantly, is the challenge on application ecosystem. What does that mean? So for computing power, we need to learn it and do it in the right way. We need to be able to create this application ecosystem, and we need it to be user friendly. We need it to be beneficial to the users, and we need them to be highly accessible to everyone. So this ecosystem need to be inclusive enough and need to be shareable, need to be accessible. And of course, it requires different types of work. And we have here the ABC for building this ecosystem. Big bay, big application, and big opportunity. So we have some of the fundamental work. For example, the basic softwares and computing database, etc. And for the GBA, we need to identify some large applications, meaningful applications to support the development of GBA. And of course, it requires a collective effort to complete, and also big application. This big computing platform needs to be supported by large applications instead of a bunch of small applications. And what we would prefer is to have a collected power to support big applications, meaningful applications. And for basic softwares and tools, that this in particular right now is very popular. The platform we have, it's not just important that it runs, and also it needs to deliver very high performance to really create value. Just like we are building the roads, is it just a normal paved road or a highway? If it is a highway, we could have vehicles driving really fast, and that is what we're after. having just a paved road does offer value, but it is less value than the high-speed train or the highway. And we would like our computing platform to be just like the highway. And there are other major applications, for example, in healthcare and etc. As some are also supporting some national strategies to really create value. So it comes all down to talents. This super computing power, and especially if you want to have a leading computing power platform, the core is talents. And we need talents that have cross-disciplinary know-hows, and this is not easy to find. If we want to stay competitive, we would like to be able to attract all these talents. And that's how we really create value and make an impact. Okay, just to conclude my presentation, first, computing power is the basic for a new technology revolution and industrial revolution. Transportation is infrastructure. Highway, airports are all infrastructure. So we need to build the infrastructure in a new era. And that's what we call it, a new infrastructure, and of which computing power is the key. And second, for the GBA to develop and to have high quality development, and we need to have computing power. And later we're going to have the inauguration of this new computing power center, the Hong Kong Shenzhen Global AI HPC Center. And we would like to leverage this opportunity and to really make a difference. And I think this is crucial for every one of us. And thirdly, we are still facing various challenges when we transfer computing power into productivity. Computing power is not always productivity, and but we need to really convert this computing power into productivity, and the key to that is to build the right application ecosystem. Without this application ecosystem, we cannot transfer computing power into productivity.
We often say there's a computing power economy. How can we realize that? We need talents. Without talents, we cannot fully realize the computing power economy. So we have to attract the talents and retain them, and that's the guarantee of the future, and also the guarantee of the future of our social economic development. So we have to retain the talents. So that's all I want to share with you. Thank you for listening. Later, our Hong Kong and Shenzhen International Computing Power Center will also be launched. I wish every success to this center and also play its due role in the GBA area. Thank you all. Thank you.